All right. So chapter 4 is about that word, quadratic functions. Now, what did you just finish?
Linear.
We did linear. Good. So we did linear, and linear is basically a line y equals what? Mx plus b. That's pretty much what you and I just did. The one thing about linear is your y is raised to the first degree, your x is raised to the first degree. If you've got first degree xy, it's linear. So what do you think quadratic's going to be?
Square.
Yeah, it's going to end up being, you're going to get an x and you're going to get a square behind it. The x squared makes it quadratic. The other thing I want you to know, quadratics are not lines. They're what? They're what?
Parabolas.
Parabolas. So basically, if you want to know what a parabola is, well, you can kind of see it right there. It is actually, it looks like the letter what? U. It looks like a U or an upside down U, something like that. And I'll tell you why they go up or they go down in just a little bit. Okay? So basically, this is where you're going. You're going with quadratics. You are now done with linear. But I don't mean you're done with linear because linear keeps coming back. Okay? What else are we going to do?
Transformations.
And transformations are just basically take the parabola and do what to it? Move it right, left, up, down, stretch it, compress it. What else can we do? Reflect it. Reflect it over the x-axis. Okay. Yeah, we can do all that stuff. So that's what we're going to do. So really, I don't think this is going to be hard for you, this piece. I don't think any of this is hard. I just think it's a lot of terminology today. You got to listen to what is being said. Okay, here's a quick little opening on what's a parabola and where should we place this parabola. All right. In the computer game Steeplechase, you press the jump button, and the horse makes the jump shown. Here's the jump over here. Okay. The highest part of the jump must be directly above the fence, or you will lose time. Your horse might trip, fall, whatever. Where should this horse be when you press the word jump? 4. At 4, right there.
Or like a little bit.
Okay, you're saying 4. Where else should it be? Or does everybody want 4?
2.
What?
2.5.
2.5. Anybody else?
3.5.
3.5. Okay, good? All right. They said there's the jump over there, right? So you look at the jump and you go, oh, the highest part of the parabola is right here. Isn't this where you want the horse to be at the top, right over the fence? Okay, but here's the deal. How long did it take to get to the top?
2.
Well, if I go down, there's the number 2. But where did the horse jump? 1, 2 units back here. You have to back up 2 units before you get to the peak. So if you back up 2 units, where is this position, the fence? 4.5. So if you back up 1 unit, 3.5, 2 units, there it is. The horse, if you're going to do this, you want to make the horse jump right at what? 2.5, because by the time the horse jumps at 2.5, it's at the peak. And by the way, it will land where? Where do you think it's going to land?
6.5.
6.5. How'd you know it was 6.5?
It's 4 units.
The whole thing is 4 units, and the peak is positioned where? Right in the middle. Okay. When it comes to parabolas can be cut in half, and they are symmetrical. So if this is 2 units left, this is 2 units right. So because they're symmetrical, it's really nice when you get to graph them. Because if I were to graph this, I would find this point. I would find this point. I would mirror it over, just like this point. I'd mirror it over. Do a lot of mirroring in this chapter, and you don't have to do a lot of work. If you want to work hard, then work hard. Go get all 5 points. I like 5 points. When you graph 1, 2, 3, 4, 5, this point right there is known as the what? The highest point of the parabola or the lowest point?
Max high.
Well, this is the highest, but what is this called?
Vertex.
It is the vertex, yep. So we are talking the highest or lowest point is called the vertex, okay? It's all coming later. Here comes the vocab now. Okay, here we go. All right. This one is just looking at these old functions. And by the way, these functions, they're V's, so they're absolute value functions, right? Okay, circle the vertex is all I want you to do. That should take you, honestly, 2 seconds. Okay. Here the vertex is at the lowest point on the bottom of the V. Here it's the what point?
The highest.
Highest. Another name for highest, they call it the maximum. This one they're going to call it the what? Minimum. This is what? Minimum. I'm only throwing these words at you because they're coming with quadratics. Yep. There's your calendar. Do you have notes? Did you grab notes when you walked in?
I did not.
Okay. All right. Here you go. We're actually right here. We just finished this.
Appreciate it.
Okay, so we got maximums, highest point, minimums, lowest point on absolute values. Well, the same thing happens on parabolas, okay? It says here a parabola is the graph of a quadratic function. A function of the form, right there. Now, you know, it'd be kind of nice if you guys would also go like this. Y equals, or f of x equals, ax squared plus bx plus c. This form that you see right here is also known as standard form. So the standard form of a quadratic function is ax squared plus bx plus c. Okay. All right? Now, what's a dead giveaway that it's a parabola or a quadratic?
The square.
Yep, right here. This is why it's quadratic. It's quadratic because of this little 2. Once you see that 2, that x squared, you have a quadratic. You have a parabola. Okay, a parabola is symmetrical around its axis of symmetry. A line that divides the parabola into 2 mirror images. So you can just find a point on the left, mirror it over on the right. Okay? So, axis of symmetry. This is what we're symmetrical around, okay? Now, watch this. See if you can answer this question. This is 2, 1, okay? Okay, here we go. Go here, I'll go here. This is going to be 4, 5. Okay? So here's the thing. I gave you a point and a point on your parabola. There's something called the axis of symmetry. It's a line that cuts this thing in half. Okay, if I gave you 4, 5, there should be another point directly where? On the left over here. Should be. What's that point?
0, 5.
Say it again.
0, 5, 0, 5.
Okay. I agree with 5. How'd you know it was 0, 5?
It's because the distance between the axis of symmetry and the other point is 2,
Okay.
and then I guess the other distance would be 2 minus 2.
Right. So to get to that 4, what did I have to do? From this 2, I added 2 to get to that 4, correct?
Yeah.
Okay. Well, if you want the other side, it's just going to be not add 2, but subtract 2. So this would have to be what? 0. Does that make sense? If parabolas are symmetrical, you can mirror them across, and you can almost get them without even thinking about it. If you had graph paper, would that be easy? That'd be so easy. You know what? This point's here, but this point's also on there. This point, they're just mirror images of each other. So when you guys graph parabolas, all I would do if I were you is this. Get 1 point, get 2 points, get 3, and then do what? Just mirror it. Just mirror it, and you'll get the rest of the parabola. Okay? All right, going back to where we were. All right. Okay, where am I at here? Okay, here they were just trying to show you that the axis of symmetry cuts your parabola in half. What point does it actually go through?
0, 0.
Well, yeah. In this one, it is 0, 0. I was hoping you'd say it always cuts through the vertex. Always cuts through the vertex. Always hits the vertex and keeps going. Okay? All right. Circle each function. Now just look at these 4 functions. Circle the function whose graph is a parabola. Takes you 10 seconds. Here I numbered them for you. 1, 2, 3, 4. Which ones are parabolas?
2 and 3.
2 and 3? 2 and 3. Why?
Because they're squared.
Because they've got x squared, x squared. What's this?
Absolutely.
Linear. This is linear. X the first, y the first. This is what? Linear. Okay. Any ideas what this is?
Cubic.
Those are cubic functions. We'll do them later. But I mean, when you start getting higher degrees, you get into different things. Cubic. They have a certain look to them too. Okay. Number 3, cross out. Just cross it out. The functions who are not parabolas. So which ones are not parabolas?
2 and
2
4.
and 4.
2 and 4? Because 2 and 4 are considered linear, right? Okay. Okay. All right, next. The old parent graph. All right. So what does the parent quadratic function look like? It's basically right here. I'll come over here and I'll drop it down. Instead of f of x, I'll just go like this. This is considered the parent function. It's the most basic thing a quadratic function can do. Now, I don't know what your memory is, but I feel like I did talk about this the first week or 2 weeks of school. The parent function will always have a vertex where?
0, 0.
0, 0. Now, if you put 0 in, 0 squared is 0. So you can do these tables. These tables work every time. They're just very time consuming. So if you go 1 to the right from the vertex, 1 to the right, how high up do I go?
1.
And you know that because 1 times 1 is 1. If you go 2 to the right, how high up do you go? Yeah, you should know that one too because 2 squared is 4. Hey, really quick, what if I put a 3 there? 9, you go 9 up. Even though they didn't graph it, that's what you do. Okay, now, if they ever tell you in the book to go make a table, I feel like I'm done. Because really, if this is the vertex, 0, 0, if I go 1 to the right, I go up 1. Well, what if I go 1 to the left? Don't I just go up 1? So I'm stealing this point, aren't I? Okay, what if you go 2 to the left? Steal that point. 4. So you don't really have to generate these answers. They just come out just by looking at it. Is everybody okay with that? Now, here's the deal. Do you think I like tables?
No.
No, I hate tables. Here's the deal. I want you to memorize what the parent does. So, let's memorize what the parent does. Okay, here we go. From the vertex, which always starts at 0, 0, where do you go?
Over 1,
Over 1,
up 1,
up 1, over 2,
up 4,
up 4, over 3,
up 9.
up 9. You hear that? So, there's that side, and then this side would be mirror it, mirror it, mirror it, and there it goes. If you can memorize that, you will be so much better off, okay, than making tables. All right. This is problem 1. I did this last hour. I don't want to start with problem 1. It confused them So I'll do problem 1 last. I will do problem 2. Okay, let's do problem 2. Would you please graph that? F of x, or sorry, they call it g. G of x equals x squared plus 3. And now think of your translations. Do you remember what happens to the parent graph if you just put a plus 3 in the backside?
Left 3.
Left,
3.
up. Who wants left?
No.
Okay, we got 2 people that want left.
No, it's up.
Who wants right?
I feel like it's up. I
Who
don't
wants
know.
up? Who wants down? Oh, some of you didn't even vote. Here's the deal. If you take your, isn't this your parent right here? That's your parent. And you put a plus 3 in the back, it means take your parent and do what?
Up.
It's just up 3 is all it is. So if you take your parent, and by the way, your parent always starts at 0, 0, you would go here and call that your vertex. 0, 0 just becomes 0, 3. Now, here's what I'm trying to tell you. If you want me to, I can do this. I can put numbers in with you. Go 1 to the right of 0, you get 1. Go 1 to the left, you get negative 1. And you can plug these numbers in and get answers. Or you can just look at your graph. Your graph over there is going to act just like your parent. How do you know? How do you know it acts like your parent? And nobody can tell me. Okay, see x squared? What does it have in front? What's the number?
1.
If you have a 1 in front of x squared, it acts just like your parent. So where would you go from the vertex? 1 to the right, up 1. 2 to the right, up 2. And there's half the parabola right there. And to get the other side, wouldn't you just mirror it? Yeah, go straight across, right there, straight across right here, and just go straight up, like that. There it is. It's just your parent slid 3 up. Now, if you wanted to, you would just put this there, 2, negative 2. What's the answer here? If you move 1 to the right, go up 1. If you move 2 to the right, go up what?
7.
Well, go up 4, which makes it 7 and 7, right? Okay. The table is not that necessary. But if you like tables, put them in. Does everybody understand how you put a 2 in and you get 7 out? What's 2 times 2? 4 plus 3? 7. See, it comes out anyways, right? Okay. Personally, I think most of you are going, I don't want to make tables. Maybe not. Maybe you guys love tables. Okay, how about this one? Graph g of x equals x minus 4 squared. How is this graph? How is the graph of a translation of the parent?
Right.
This one is what?
Right.
Right 4 units. So where would the parent go? The 0, 0 vertex would go where? Right 4 and become what? 4, 0, right? Okay, so the parent slid right 4. And that's all the parent did. Hey, where's that number 1 again? Remember the number 1 sits right here? And if it sits right in front of x, it is the parent. Where's the 1 in this one?
4, 0.
5,
It's right. For the parentheses.
Right in
On
front
the
of
other
it.
side, yeah.
Right there. There's a number out in front of the parentheses. It's 1. If it's 1, it acts just like your parent. Which means go over 1, what? Up 1. Go over 2, up what?
4.
Okay, and then you can just mirror it, sketch it, call it good. Okay. Again, if you don't like that, just make a table. Here's the vertex, right? Go over 1, go back 1. And if you put these numbers in, watch how easy this is. Put the number in. What's 5 minus 4? 1. Square it. 1. 1. I can generate a table so quick. Here's the problem. I can do that even quicker. I can graph these quicker than I can do this. So I'd rather just do that than make tables. Who wants to make a table? Do you guys want to make a table? Raise your hand if you do. And nobody dares raise their hand because they don't want to be known as the person who likes tables.
How do you make a table?
I just did it.
What was it?
I said, you told me, right, you said move right 4. 4 zeros called the what? That's the vertex, right? Okay, if that's the vertex, if I move 1 to the right, 5, put the 5 in. What's 5 minus 4? 1. 1 squared is 1. Hey, what if I moved 2 to the right of the vertex? Put a 6 in. 6 minus 4, 2. 2 squared. 4. And by the way, I have those points on.
Well, I was just gonna ask the question that you wanted to be asked.
Okay.
I don't know what it was.
You just didn't care.
No.
I don't care about you. I'm going to ask it.
Yeah.
You ever seen
I thought that was what.
All right, you ready? This is why I didn't want to start with number 1 because number 1, oh, you can hardly see it by the way. Number 1 says y equals negative 1/3 x squared. I didn't want to start with this one because it's the hardest one. Now, if I cover up this right here, y equals x squared, isn't that your parent? Okay, but hang on. What does this do? This negative sign.
it? Makes it upside down.
Flips it over. It's a reflection over the x-axis. So it's an upside down parabola. And what does the 1/3 do to your parabola?
Changes the expresses.
It compresses. It makes it flatter. Okay? Anything bigger than 1 is a stretch. Anything under 1 is a compression. So you are not going to go up quite as fast. You're going to go up how fast?
About a third.
1/3 as fast. You're only going to go up 1/3 of what the normal parent goes up. Okay, so here we go. Plot the vertex. By the way, what's the vertex going to be? 0, 0. Yeah, it is the parent. It's exactly the parent. It hasn't moved. It didn't go right, didn't go left, didn't go up, didn't go down. It has not moved. Here's what happens though. Oh, it says draw the axis of symmetry. The axis of symmetry is a vertical line that cuts it right in half. Oh, by the way, it's an equation. Say it again, Curran.
X equals 0.
It is x equals 0. The axis of symmetry will always be x equals, and it will always be this number right here, whatever that number is. Okay? All right. Step 2, find and plot 2 points on one side of the axis of symmetry. Okay, here's what happens though. You guys, typically you move, this is what the parent does, over 1, up 1. That is what the parent does. You're not going up that high. You're only going up how far?
A third is fine.
A third. Now here's what you do. Normally, over 1, up 1, we only want to go up how high? 1/3 of that number. Well, what's 1/3 of 1?
A third.
You guys, you're only going up how high? 1/3. Or are you going up? It's negative. You're going down. So don't go over 1, up 1/3. Go over 1, down 1/3, right? Okay. Now, let's talk again. If you move over 2, you usually go up 4, don't you?
Yep.
Well, we're not going to go up 4. We're only going up 1/3 of 4. What's 1/3 times 4? 4 thirds. Now, what is 4 thirds?
1 and a third.
1 1/3. So you're going to go over 2 and down 1 1/3. This is the look you're getting. Now, mirrored over, you get this look and this look. Okay? What if I said I want a better look? I want more points. What's that other number again? Normally, parent goes over 3, up what?
9.
9. You're not going to go up 9. You're going to go up 1/3 of 9. What's 1/3 of 9?
Three.
3. So really, you'd go over 3, what?
Down 3.
Down 3. You'd be right here. And right here. There it goes. And there it goes. You okay with that? 1/3 is not a good number. 1/3 is a messy, messy number. Because when you take 1/3 of a number, you usually get fractions. Usually. Okay? 1/2 is a nice number. 1/2 is easy to do in your head. Okay. All right. Just a quick shot at reflections and a quick shot at stretch and compression. Okay? First of all, this is the parent right here, x squared. Okay? Negative x squared. What does negative x squared look like? Take the parent and do what? Just reflect it. So if this is the parent x squared, then negative x squared would just be the same thing upside down. Good? Okay, what if you stick a number in front of the parent like a 2? Something greater than 1, it will do what? Stretch the parent. How about a number less than 1 but bigger than 0? Like 1/2. That's going to be a what? Compression. It's like pulling the parabola down half as tall. Okay? So really quick. Here is the parent. The parent is right here, and here, and here. This is x squared, right? So what is 2x squared gonna, oh shoot, I didn't do that very well. Let's just do it. Where is 2x squared gonna be? Where would this point go, guys, for a 2x squared? Put a 0 in. 0 squared, 0 times 2, still 0. Doesn't even change, does it? No, the height doesn't change. Why not? Because there was no height. Now watch this one. Over 1, up 1. That's the parent. You're going to take the parent and double the height. Over 1, up 2. What about this one? Over 2, up 4. No, this is going to be up what? 8. If you could picture that, that's 8. So here I come, I'm coming down. And I'm going to hit this point and shoot back up and go straight up like this. So this red one is 2x squared. Does that make sense? Okay, what about this 1/2? What's a 1/2 x squared going to look like? Well, you're not going to go over 1, up 1. You're going to go over 1, up 1/2. Over 2, up 4, up what? 2. So you would get something like this for a 1/2 x squared. Does that make sense? You guys remember doing all this, don't you? Yeah, okay. All right. Now, they start throwing the words minimum and maximum at you. Listen to this. If your A value is greater than 0. What does greater than 0 mean to you? Jamil, what does it mean? You must be thinking really hard with your head down. You don't know. Keep your head up, you'll learn something. What does this mean? If A is greater than 0?
It's more than 0.
It's more than 0. What kind of numbers are more than 0?
1, 2, 3.
You were supposed to tell me positive. If A is greater than 0, the parabola opens which way? Upwards. You got a parabola going up. Also, this is important, the y-coordinate of the vertex is the minimum value of the parabola. Okay? If A is less than 0, what's that mean? It's negative. If your A value is negative, the parabola opens which way? Downward. The y-coordinate of the vertex is the maximum value of the parabola. I know what I just said to you. Probably confused some of you. So here, let me just try this. Here's a 3x squared, and here's a negative 3x squared. Which one goes up? Which one goes up? This one or that one? 3x squared goes up. How come? Because this a value is greater than 0. This one goes down. How come? Because this a value is less than 0. That's as simple as I can make it for you. The other thing I want to tell you is this. Oh, this is such a bad example. If I put a 5 there, this point right here is 0, 5. If I put a plus 5 here, this is also 0, 5. Okay? Is this a minimum or a maximum point? Minimum. It's the lowest point. So you're going to be asked, where is the minimum? And you'll say, the minimum is the vertex. And it happens where? Where the y value is what? 5. So what I'm trying to tell you is the lowest part of the parabola happens at 5. What is that called? Minimum or maximum? Maximum. So you have, in this one, you have a maximum at y equals what? 5 again. Okay? It's really important that you know the minimum and maximum point. Okay? That's what all that said. So that picture I just showed you, was that okay? Did that kind of rephrase all that? I mean, when you think about what they said, that's really all they were telling you. Okay? All right. Oh, too high. Okay, now I have to write this in because this won't move for me. The vertex form of a quadratic equation is this. Well, I'm going to write this in for you. Y equals a. It's no longer x squared, guys. It's going to be x minus h squared plus k. That's called vertex form of a quadratic equation. Okay, I want to go from there, and I want to go down to here. The vertex of the parabola is blank blank. Anybody know? Look at this. You can read the vertex right out of it.
H. No.
Say again. Isn't this telling you, take your parent, slide it which way?
Right.
Right how far?
H.
H. H to the right. How far up or down?
K.
K. Guys, when it's written in this form, your vertex is HK. The equation of the axis of symmetry would be x equals, here's HK. Goes right through the vertex, axis of symmetry. What's it?
Plus K.
No.
H.
Isn't it always going to be going through the x value of the vertex? X equals h. Just h. Okay? So guys, if this was 3, 6, your axis of symmetry would be x equals what? 3. That's what I'm trying to tell you. Okay? Alright? Next picture right here. The vertex form, what you see, gives you information about the graph of f without graphing the function. If blank, I just have to give this to you. If a is greater than 0, which means the parabola opens which way? Up. K is the minimum value of the function. If a is less than 0, k is the maximum value of the parabola. How do I explain that one? I think this is all it is. If you have this look, okay, right there, if that's your vertex 3, 7, tell me, is that a minimum or maximum? That's min. That's a minimum, and it happens at y equals what? Which one's the y value? 7, it's gotta be 7. Okay, but if I go like this to you, like that, is that a minimum or a maximum? That's a maximum. At, oh, I forgot to put something here. How about 10, -1? At y equals -1. Okay? So minimums and maximums are your y values. That's all I'm trying to say. How do you know this is a minimum? Because the a value would have been positive. How do you know this is a maximum? Because the a value would have been negative. Is this the slide I'm on?
Yeah.
Okay, all right, we're almost done. We have 2 problems left and then we're done. 2 minutes?
Yep.
Oh, we're good, we're good. And I might not finish this one, but we'll get this one done. All right, what are the vertex, axis of symmetry, minimum, maximum, domain, and range? Okay, ready? Vertex. What's the vertex?
1, 4.
Negative.
Okay, Brady says 1, 4. Do you agree?
No. Yes.
Why not?
Well,
Just left.
Because x plus 1 is a shift left 1.
yeah.
It's -1, 4. Good? Okay, next. We did that one. What's the axis of symmetry? AOS.
It's equal to negative.
Well, here's the deal. -1, 4 sits there. Do you guys know if the problem goes up or down?
Goes down. Down.
Look at the number in front, -2. That's down. This probably goes this way. All right? What's the axis of symmetry? Goes right through what number?
-1.
X equals -1 is the answer. Done. Is that a minimum or a maximum? Isn't it the max? You have a max. At what y value? What's the highest y value coming out of that parabola? It's right there, it's 4. It's always going to be the y value. What's the domain? What x values actually got answers? This one did, this one did, this one did, this one did.
All real.
Yeah, all reals. Every x value gets an answer. What's the range gonna be? Those would be the y values that came out of this function. Before you leave, you gotta say it.
Y is less than 4.
Y is less than or equal to 4. 4 is the highest that ever came out of this function. The next problem is the same thing. Just do your assignment today. You're supposed to say, there is no assignment. Okay. Yeah, that -2 is just this. All the negatives are from the vertex go over 1 down 2. Over 2 down.
Inside with that 1, x plus 1.
No, once it's in vertex form, which that is, then by you saying a number x plus a number x minus a number, it's already been shifted right in.
Yeah, but if I were to like solve it or something.
Right, I know what you're saying. You're saying x plus 1, if I square it, I get x squared plus 2x plus 1, but then I have a 2 out here, right?
Not really, actually.
Is that what you're trying to tell me?
No, but
$30 is a dime. Here's the deal, Brady. As long as it's in vertex form, if it's in vertex form, just go right, left, up and down. And then the -2 would tell me how it's up.
Oh, by the way, it's Brandon Coons who does that handshake.
inside, because that's what we do with the x
Dude, okay.
Oh, you want me to take negative
When you
two
send an
back?
argument like that, and you go back to that.
What do you do first, the multiplier?
You
You
like
do
that?
the-
Too much. No, it's not. No, it's not.
How did you come up with it? You can't do that. When you're
Well, I
trying
didn't
to-
come up with the beginning.
You know, the order of operations says do what first.
How did you
Ah.
How did you remember who you did?
You do X one.
Douglas from
X one
this
squared
and this.
is really.
Back when I don't know.
Then you would go back and then you start doing the stretch.
That is.
You have to stretch.
I just, I was thinking this
Situation.
Don't worry. Hey, bro, arguing on the board, and then you're arguing with your little butter knife.
Oh no, this word.
Did you actually do
You guys are
it?
actually trying to argue that the relatives are better than you.
I'll make you I'll show you.
The worst fucking thing I've ever seen.
Notes are right there, grab them.
Hello.
When do we get our test?
I missed this class, even though it's the hardest thing in the world.
Test grade.
Jones
Yeah.
class.
It is so
Ah, maybe.
class
These
every day.
things are thick.